Just a very quick video on one specific point. Some of you may wonder what happens to the horizon when you go up in a plane if the flat earth model is correct. And the question is, does it stay in the same place since there's no curvature, or does it go down because there's a curvature of the earth and you're viewing the earth from a higher up vantage point, so therefore the curved surface will have it be at such an angle that it appears lower. And I like to address that issue. I believe it's very standard for flat earthers to use the phrase, the horizon is always at eye level. I find that phrase vague, but I don't want to comment on it, but I think that position has to be incorrect because, okay, so let's get to the point. For both the heliocentric model with the sphere Earth and for the flat Earth model, both models will lead to a lowering of the horizon in the distance from a jetliner at 30,000 feet, for example. A significant lowering. It has to. It's a very simple issue because of light bends in a specific way. It's called light refraction. If you think it's not real, go stick your hand in a lake and you'll notice your limb bends at the point, in its appearance, at the point of going in the water, because light is bending through, it travels at a slower speed in water, therefore bends, changes its direction, it makes it look like your arm's in a different place than it actually is. That's why the sunset happens, and that's why the horizon lowers when you go up in a plane, as we're going to find out here in a minute. So refraction is no conspiracy theory or no wacky idea. It's something that all of us have seen in our life many times, and it's a standard. One of the many standard aspects of light distortion when light travels through air. But you can go measure this. Go get in a plane tomorrow and lock your cell phone onto the window, which I did when I was traveling from Denver to Detroit recently, and you can measure where the horizon ends up, and it turns out to be, it lowers quite a bit. It's a very simple experiment. Here's the issue. It's extremely standard for professional academics to discuss the sun as appearing artificially higher in the sky than it typically is throughout a given day due to light refraction, except when it's right near the horizon in the distance. At that point, it's where it's visible from, it will lead to an artificial lowering, and that's why the sun sets. In other words, it refracts downward in appearance more than the land closer up to you that composes the horizon, which is not as far away and does not refract downward artificially as much. Anyway, see my Zeteticism Volume 1 video for a much better explanation of that. But you're viewing the sun through a lessening density, and then that's why the sun will appear artificially higher, which I discussed also in that Zeteticism Volume 1 video. But this is an extremely standard measurable issue, and the sun changes and squashes in its size and so forth as it's moving through the sky in various predictable ways daily in different positions, because light refraction is distorting its sphericity appearance from our position on the earth. So when you're viewing through a lessening density, it'll appear artificially raised. It's higher in the sky than it appears higher in the sky than it actually is. Now, when you're in a plane, the exact opposite vantage point, you're viewing in this case, the horizon through an increasing density. Therefore, instead of appearing artificially higher when you're on the surface of the earth looking through the lessening density, it will be artificially bent. Light will be refracted upward, and an object will appear artificially lowered in the distance on the horizon. Again, this is what appears to be exactly the same process that's responsible for the sun dipping below the horizon, as it's called, which is actually dipping behind the less refracted light that makes up the horizon. As just said, watch that video I just referred to for explanation. So the point here that's being made is that the horizon will lower when viewed from a plane or going up in a balloon or whatever in a measurable way. And it is, if you want to claim, is it due to curvature or light refraction? Well, both models, flat and sphere Earth, will involve the horizon lowering and the horizon lowering from a plane. This flight you're seeing here is from me going from Denver to Detroit recently. At about just a few minute or three after takeoff, the plane turned. It was turning, so when it finally finished turning this long turn, it leveled out, and I could start filming the horizon. I locked the camera, and what it basically did is just held the camera against the window in the exact same way as the plane was ascending. Presumably, this will give us the same view out of the window, which we can compare the start and the end to see if, from that locked position on the window, if the horizon stayed in the same place. Because presumably if the plane is level at the ground and level up high, it's going to measure the horizon from the same positioning. Therefore, if the horizon moves and the camera is in the same positioning, it'll be detectable, which is what was found. Horizon lowered a lot. So I don't know of anybody who's measured if the horizon lowers in appearance or not when elevating significantly in the air on a balloon or plane or something. So I just wanted to contribute this because I hear a lot of people talking about this and discussing the horizon does this or that, but I haven't really seen many measurements. I bet there's some out there, but I hadn't seen them, so I wanted to put my own up. Another thing that's interesting about this video is the sun did not go down at all. Of course, we're seeing it with a lot of rays, and we're not measuring really where the sphere surface of the sun is. But nevertheless, if we can go by the illuminated appearance, the sun stays in exactly the same position. Which would imply the sun was significantly higher than the plane and not, for example, at cloud level or something. Since the jetliner, of course, goes above cloud level, I think this would be rock solid proof that the sun is significantly higher than the plane. 3, 5, 7, 8,000 miles up. That's the zetetic position I hold. I'm aware of the video footage of the idea that the sun is in the clouds, and I know it's compelling. I've studied it extensively, and I've got an upcoming video about that, which, believe it or not, I think is going to show that the sun's not in the clouds. That the sun is in the clouds is, amazingly, an optical illusion. You have to really look carefully and find evidence for that position. But anyway, I'll present that later. But apart from that, this plane footage here that anybody could duplicate would appear to be drop-dead proof that the sun is not at cloud level, as is so widely claimed by flat earthers nowadays. So as you can see, we've been comparing different stills extracted from the plane footage and comparing them, and the horizon is clearly observed to move down. The cell phone stays in exactly the same spot when you compare it still to still over that 12 minutes or whatever it was as the plane went from just after takeoff to cruising altitude. Sun stays in exactly the same spot. The cell phone does. Horizon moves clearly lower. Now, likewise with the ground, the horizon, when in a jetliner, when the plane ascends at cruising altitude, the sun will be viewed through a lessening air density, being higher up, and therefore why it stays in exactly the same position, and with respect to how it's viewed in different air densities, but it nevertheless stays in the same position. All that would have to be discussed. It's really an amazing situation because there's two models that describe the same issue, and both describe it to some degree. They're going to stray from each other on mathematical accuracy and so forth, but keeping it more simple in that discussion, the light refracted view model would involve objects appearing artificially lowered more and more progressively further in the distance, but that looks exactly like a curvature scenario. So the two, you really have to verify which model is correct. So anyway, that was the point of Zeteticism Volume 1. I tried to verify if it's this appearance of lowering of objects in the horizon is from curvature or light refraction. It was found that it's from light refraction, and there'll be more volumes in this series coming out on that. So I'd like to repeat that absolutely anybody can repeat this experiment. All you need is an airline ticket and a camera. Make sure you anchor the camera in the same spot if you move it around at all like I did through the video, And so this is pure science right here. Anybody can repeat this simple science. I hope this doesn't upset anybody either way, but you know, you shouldn't really be upset because I'm just reporting the evidence. It doesn't really have anything to do with me. Take care.